Okay, so in this video we'll go through the different types of connective tissue. So connective tissue is unique because the cells are very widely spaced from each other and there's a lot of extracellular matrix. Connective tissue is the most abundant and most variable. It is basically all the tissue that doesn't fit into epithelial, nervous, or muscular. So for example, your tendons and your ligaments, your blood, your fat, all of that is connective tissue. So we have different types. This unit we're just going to go through fibrous connective tissue. We'll go through supportive connective tissue in Unit 2, and then fluid you guys will go through in Bio 202. So cells are named based on their function. So if you see the suffix blast, this means it is secreting new matrix. If you see the suffix site, it means it is maintaining. Some prefixes here. Fibro means connective tissue. Chondro means cartilage. Osteo means bone. And hemo means blood. With those prefixes and suffixes, you can now name a lot of different tissues. So fibro means connective tissue. Blast means it's building. So fibroblasts are cells that are building fibers in their connective tissue. Macrophages are immune cells that phagocytose form materials, and what they do is they basically chop up the foreigners, the bacteria, and display a small piece of them to alert the rest of the body to start attacking the bacteria that are invading. Mast cells are secreting heparin, which inhibits your clotting process. They also secrete histamine, which dilates your blood vessels. Histamine is what's responsible for your allergic reactions. So if you get a really allergic reaction from like a cat or a dog or something, your eyes get really teary, you might get redness, you get a runny nose, all of that because your blood vessels are dilating. Adipocytes are fat cells, so adipose is fat, cyte is cells, so this is storing fat. Chondrocytes are maintaining cartilage, so chondro is cartilage, cyte is cell that's maintaining. Osteo is bone, blast is build, so osteoblasts are building bone. What would you call a cell that produces bone, maintains cartilage, and produces connective tissue? So a cell that produces bone is an osteoblast. Cell that maintains cartilage, chondrocyte, and fibroblasts produce connective tissue. We have different fibers within the extracellular matrix in connective tissue. So, excuse me, collagen fibers are the most common. These are tough and thick, but they are also a little bit flexible. So these are what you find in your tendons and your ligaments and within your skin. Reticular fibers are thin and they have glycoproteins and they form kind of a framework, kind of a skeleton for your lymphatic system. Elastic fibers, just as they sound, they are made out of something called elastin, which gives elasticity. This is really important so that you can stretch and return back to normal. The ground substance is just this gelatinous, rubbery, kind of gooey, jello-y material that's found between the cells. It's made out of lots of different molecules. I don't care that you know the specifics of it for this intro Bio 201 class. This is a picture of one of the molecules found in the ground substance. Okay, so we have two types of fibrous connective tissue. There's loose and dense, and we will go through each of these. Same idea, you should know the name, location, and function for each. First type of loose connective tissue is called areolar tissue. It looks like a scrambled mess, but this underlies all your epithelium. So this provides a structural support for all the nerves, all the blood vessels, and anything else that needs to be within here, like your immune system. This you find in the dermis, which is a layer right below your skin. Reticular tissue looks like this. This forms framework for your lymphatic system, kind of like skeletal structural support. You find this in your lymphatic system. Adipose is fat. This is good for energy storage, and you find this in the fat. Dense regular is nice and pretty, parallel running lines. This allows for a lot of strength. So this is what we find in our tendons and our ligaments that hold our muscles to our bones and hold the bones to other bones. We need a lot of strength here so that we can walk, jump, run around, fall down, and not break things. Dense irregular allows for stretching to happen in multiple different ways because of its random structure. So this withstands stress. You find this in the deeper part of your skin. This allows your skin to be stretched in any different direction and have it not tear. Dense regular, so yellow elastic, just like it sounds, is elastic fibers, and this allows structures to expand and return to their original size so they can stretch. This you find in the vocal cords and in other locations as well. The supportive connective tissues, cartilage and bone, we'll go through when we go through cartilage and bone next unit. Fluid, you guys will cover in Bio 202. And here we'll go through some diseases. So the first is called Marfan syndrome. This results with individuals that have extraordinarily long limbs. They might have long facial features, and this is because of a mutation in their genetics that creates elastic fibers. So they don't have quite the same elasticity in their connective tissue, which can cause big problems for their arteries and veins. Lots of people that have Marfan syndrome have to have surgery in their heart when they are very, very young, just to try to prevent the bursting of the arterial or venous systems, which does not go well. Osteogenesis imperfecta, you guys may have heard of this as brittle bone disease. This is because there's not enough collagen in the bones. So collagen gives flexibility. If we don't have any flexibility, the bones shatter pretty quickly. Scurvy, we don't really talk about very much anymore, but this is from a lack of vitamin C, which prevents collagen from being formed. This collagen is what's found in your skin to give it nice stretching and flexibility. If we don't have that, we can't stretch and we'll get hemorrhages under the skin, and then it also impacts the wound healing. So if you get a cut, it might not heal for months because you don't have enough vitamin C. Scurvy is really rare in today's day, but for like sailors at sea for a long time, that's where this was discovered.